Welcome to aminacademy.com. In physics, regarding circular motions, let us do some solving problems. Look at this an example. An 8 kg object move around a circular trough with a radius of 20 cm with a constant speed of 6 meter per second. Find the magnitude and direction of the acceleration of the object. The second one, the net force acting upon the object causing this acceleration. Here, mass is 8 kg and revolves around a circular track of radius 20 cm. Radius is 20 cm, constant speed is 6 meter per second. Here, the given things first. Mass m equal (8 kg). And a circular trough with the radius r equal 20 centimeter, which is equal 0.20 meter, converting meter, and velocity v equal 6 meter per second. Now we have to find the magnitude and direction of the acceleration. Acceleration A equal v squared by r. V is 0.2 into 0.2. V is V6. 6 squared by r is 0.2 equal 180 meter per second square. Now this direction is towards the center. The direction of this acceleration is towards the center. Here the acceleration tangential. This acceleration is tangential. That means that straight line also which touch the circle and perpendicular to the center to the point of touching. Next, here the net force of object upon the object causing the acceleration. Net force, that is F net, equal to mass into acceleration. Mass is 8 kg into acceleration is 180, which is equal 1440 Newton. That net force is this much. Next question. A merry-go-round moving with a speed of 4 meter per second. A 30 kg child is sitting 3.5 meter from its center. Calculate the centripetal acceleration of the child. Second one, the centripetal acceleration is centripetal is v square by r. V is 4, that is 4 meter per second, so 4 square over r is 3.5 meter. 4 square by 3.5, which is equal 4.57 meter per second square. The second question, the net horizontal force acted upon the child, that is F net, net horizontal force. F net is that is force mass into acceleration. Mass is, the child mass is 30 kg into acceleration is 4.57, which is equal 141 Newton. We have to, next question, compare the above force with the child's weight. Here we have to find F net over weight of the child. Here F net is 141, then child weight is mg, that is 141 over mass is 30 kg into 9.81 gravitational constant, which is equal, the ratio is 1.687. No unit because it's a comparison of two weights. Here next, a cyclist, here the forces is compared, that is F net over weight. Next is cyclist move around a circular path with a radius of 60 meter at a speed of 10 meter per second. So find the acceleration of the cyclist. Acceleration of the cyclist is V's acceleration, AC is V square, that is 10 square meter per second, and 60, which is equal 1.67 meter per second square. Next question, the B, considering the combined mass of the cyclist and the cycle to be 110, what is the net force? F net is mass into acceleration. Mass is 110, then acceleration is 1.67, which is equal 183.7 Newton. Yeah. Next question. A jet plane is flying a circular path with a radius of 6.5 km at a constant speed of 2160 km per hour. What is the acceleration of the plane in meter per second? Here V is your radius R equal 6.5 kilometer, which is equal 6500 meter radius, and velocity V equal 2160 kilometer per hour, converted in meter per second is 2160 into 1000 over 60 into 60, which gives 600 meter per second. Now first we have to, what is the acceleration of the plane in meter per second square? Acceleration V equal acceleration A equal V squared by R. Acceleration is V square 2160 square over R is 6500. Let us calculate this. Let us calculate this by using calculator. So here 2160 into 2160 divide 6500 equal 717.78 meter per second square. Yeah. Next question. Next question. The race car traveling around a circular path of radius 500 meter with a speed of 50 meter per second. And the centripetal acceleration. Find the centripetal acceleration of the car. Here, simple question it is. V AC equal V square, that is 50 into 50 by 500, which is equal, that is 50 meter per second square. Centimeter acceleration is 50 meter per second square. Next question. A crankshaft of radius 10 centimeter rotates at 2400 rpm, that is revolution per minute. What is the speed of a point at its surface? Now this rpm, revolution per minute, n equal 2400 rpm, and that omega, angular velocity, 2 pi n by 60. 2 pi n by 60 equals 2 pi n by 60. I'll keep it. Now that is what is the speed of the point? Speed V equal, linear speed V equal to r omega. Here radius is 10 centimeter, that is 0.1 meter. 0.1 meter into omega is 2 pi n into over 60, which is equal, we write 0.12 into 3.142. rpm is 2400 over 60, which is equal 25.137. 25.137 meter per second. That is calculated. Linear speed is 25.137 meter per second. Now so far we have done just here. Here mass is given, radius converted in meter, v equal to 6 meter per second square. Acceleration is v squared by r. This is a tangential. Tangentially, this acceleration act tangentially. And F net force is ma, that is mass into acceleration. So we have 1440 Newton. Like the second question also, acceleration is the centripetal acceleration v squared by r, we calculated. F net is mac. Then we have to do compare the above force with the child's weight. F net by weight. F net is 1 by mg. So we have here AC same v squared by r, F net. Next here same v by v squared by r. Here acceleration of the car equal to v squared by r. Here the same AC equal to v squared by r. Next here RPM is given 2400. That crankshaft RPM is 2400. Omega equal to 2 pi n by 60. Then V equal to r omega. Linear velocity, linear acceleration, that is linear speed is a point or surface is v equal to r omega. R is radius is 0.1 meter into 2 pi n by 60. If you put the values, we have 25.137. We have done. Please subscribe our YouTube channel.